Two. Okay, I think it's recording. Yeah. Okay, hi everyone. Thank you for coming back. So this is week 6, bias, confounding, effect, modification. Okay, before we start, anyone know what's the difference between all these three things? Anyone heard of bias, confounders, effect, modification?
Confounder is it affects what is it called? It's one of the component that affects the outcome.
Okay, Samuel, have you heard of any of this?
Yeah, whether the precise definition. Yeah.
Oh, we can just try in your own words. Okay, skip. Sunshine?
I'm not sure whether it's the same term, but effect modification sounds like whether there's a interaction effect.
Okay. Ken, I'll answer after the class, or you can find out after the thing. Okay, let's start. Okay, let's start. Okay, so talk about bias, confounder, confounding, effect modification, and some key takeaways. So it's quite a short one. That's why I have a quiz. Okay, so what is bias? Okay, so this is the layman term of bias. I'm biased against the person. Means I look at him, I don't like him. I'm not happy. Okay, or there could be gender bias. Okay, I prefer male than female for whatever reason. So basically, a bias is a tendency, an inclination, or prejudice towards something or someone. That's the layman definition. It's also unreasoned and unfair distortion of judgment in favor of or against a person or thing. So some people say, those Chinese, right? They say 八字不合 means your horoscope crosses. Just don't like the person for whatever reason, some bias. A strong feeling in favor of or against one group of people or one side in an argument, often not based on fair judgment. So recently I read about this economics. So I realized economics is actually biased. Anyone learn economics? The current teaching is very against controlled economy. A lot of times talking about the market forces, talking about laissez-faire means let the market decide. But a lot of times this may not be the best way of economic development because you need to have some sort of central development, otherwise there'll be a lot of destruction. But anyway, the main purpose is that nowadays a lot of economics teaching is in quite a biased manner towards free market, yeah, and so on. Okay, now we talk about bias in epidemiology. Okay, this is something you need to remember. Okay, is any trend, okay, in a collection, analysis, interpretation, publication, or review of data, leading to conclusions that are systematically different from the truth. So a key thing about bias is it must be systematic. You remember physics? Random errors, systematic error. So the bias must be systematic. It cannot bias one side and bias the other side. Then it's not really a bias. Okay, so this one thing. It must be systematically different from the truth. Okay, so these are the definition of bias. Any questions so far?
So it's the plus
It either bias to this way or bias to the other way.
plus minus.
Yeah, okay. And okay, later we'll get more concrete example. Okay. Can any question? Move on. Do quite a short one. So this is what I mentioned. The measurement is very precise. So the confusion is about accuracy and precision. So you can be very precise, means all your shots are at one side, or you can be very random, but they're all clustered around accurate value. Okay. So for example, if you use a measuring tape that is stretched, means that it's overly measuring. Okay, so you'll always be either too high or too low. Or you're reading for a single angle. I think they learned this in physics, when the vernier caliper and the measuring, what's that? Vernier caliper and micrometer, is it? Can't remember already. Yeah. You still remember vernier caliper? Okay. And the angle, you must look at it for 90 degrees, otherwise it'll be an error. Random error could be reaction time. Sometimes you're faster, sometimes you're slower. And then, or you get people to take turn reading the readings. So everyone is different. But if everybody read enough, you have the large number, all the errors should cancel out. Okay. And then you round values up and down. So again, when you round up and down, if it's all in the same, in different direction, then about same thing. So there's this famous saying that I think a lot of time scientists, or a lot of people actually have fallen this error. I'd rather be approximately correct than precisely wrong. Okay? Because a lot of times people are focusing on a lot of precision. But if you focus on precision, not realizing that what you're measuring is actually wrong, it can be precisely wrong here. Okay? And a lot of times, approximate is good enough because you're surrounding around the actual value. Okay, so be careful when you talk about this. Okay, so I think I try to remove this. How to remove this? Hide.
Drag it.
Oh, not hide, not hide anything.
Remove. And
Yeah.
drag to
Okay, okay, any question? Okay, move on. Okay, so three category of bias. Okay, let's, instead of going through the details, let's talk about selection bias. What is selection bias?
you choose.
They give a simple example in a boxing match, right? I purposely choose the heavyweights, okay, versus the lightweight. Then there's a bias, right? The heavyweight will win. Okay, so when you talk about selection bias, a lot of times when you talk about a lot of experiment, right? When you do a randomized trial, what sort of patient do you select? Do you select the average patient, or you select a very compliant patient? The patient will just follow everything you say. The patient who's willing to do anything for you, or you select somebody who don't want to do anything, don't down for follow up. So who are the patients you choose in a randomized control trial?
By right.
Yes.
Easy one.
Yeah.
By right should be average.
By
Is it?
average.
Is it?
You're recruiting them, you know.
That sign up.
Yeah, those that sign up, they're a bit different, you know. People who sign up are very different from those who, people who sign up agree to consent is very different from the general population. There are some differences. Lah. You go to a lot of a lot of the CCA, a lot of these activities, right? People who sign up for these activities are a bit different. They call it the evergreen. They always go for health screening. They always go for all these activities. They're very, very activated. Not those that are stay at home, don't do anything one. So they may not represent the actual patients. Okay, so this is something about selection bias. What about information bias?
What you listen to.
Okay, one of the most common is called recall bias, because I ask you, okay, are you a healthy person? Even the most unhealthy person will say, I exercise maybe once a week, once every 2 weeks, because they don't want to be seen in a very bad shape. So the information they give you may not be accurate. This is some sort of a bias. Yeah, if I ask people those who smoke, whether they smoke during pregnancy, most women will say, I don't smoke during pregnancy. Hey, no, I saw you smoking. Okay, because they want to have a certain image to the responder. They don't answer because there's no reason to tell the truth. They may hide certain things. They may not say the things. Like, for example, do you commit crimes? I doubt anyone will say I commit crime. Or you ask people who take vaping. You go and ask the people in the vape, do you vape? If they say yes, you arrest them, send to police. If you say no, then you find, how come vaping rate is so low? Because people may not tell the truth. Okay, this is some sort of information bias. Okay, confounding we'll cover more later. Okay, any question between selection bias, information bias, and confounding? Okay, move on. Okay, so selection bias is when the probability of being included in a study is related to both the exposure and the outcome, leading to a biased estimate of the association. Okay, the very simple example is Bayesian bias. Okay, Bayesian bias means when for a lot of case control study, your cases are from the hospital, your control may also be from the hospital. Okay, but maybe that's the design of the study. It's not in the general population, and therefore there is not the true representation of the general population. Some of these can think of this as internal validity. A lot of studies have internal validity, but no external validity, depending on who is your sample. Another one is called healthy worker effect. In general, workers are healthier than retirees or those who cannot work, and therefore, if you do a study on healthy workers, you find that they're healthier than ever. I give an example during the WhatsApp, I'm not sure remember, that during the World War, handicapped people live longer. Because if you're young, you're not handicapped, you'll be drafted to war. Then you die. As compared to the handicapped, they may not be drafted to war, and because of humanitarian reason, they may be treated better. Because you're a bit of handicap, the Nazis, they may not treat you so badly. Okay, Nazis is a bad example. The British soldiers may not treat you badly because you're handicapped. Okay, in Nazis Germany, it's the other way around. If you're handicapped, they'll kill you. Okay, but let's say in a normal situation, if you're handicapped, you may be treated better and therefore live longer. So these are some of the selection bias, depending on who is your selection cohort. Okay, any question? Okay, Bayesian bias and healthy workers bias. Okay. Okay. Okay, so how do you minimize bias? Because after you know there's a bias, how do you minimize it? So first thing is you need to select representative controls. Make sure your controls represent the study population. Okay, a lot of time people like to do a control on, let's say you do a study, you want to do a controls on, let's say, our colleagues. But our colleagues is different from the person in the street. They may not be so interested in healthcare. So you take a controls from us, that is actually a bias. So in theory, you should take the controls from the population, not just people who work in healthcare. Okay. Another thing that we try to do is this thing called reducing non-response. What is response rate? Anyone done a survey before? So, okay, in a survey, right, usual in Singapore is about 50%. Okay, 50% is very good already. Okay, why? Because the non-responder are usually very different from responder. Okay, so another study, what they did was they go to the patient's house and then do a survey. What bias does it introduce?
If they refuse,
Okay, other than that, what else?
more accessible place,
What's the problem of going to the house?
inaccessible.
Okay, one of these things is that who are the survey people? The survey people usually work in the daytime. So imagine you go to the survey houses and it's in the daytime during office hour. Who is at home?
Unemployed.
Those not working, those unemployed, those elderly, right? Then okay, your result very different. Most people stay at home. You see, I found that 80% of those I surveyed stay at home. They don't work. They come out with an unemployment rate is very high because you only survey those at home. So where you survey also matters. So I think within our survey, we survey the, if you ask Li Xia or Chun Wei, we survey people living in home, right? In that survey, they excluded people staying in condo because condo cannot go in. So there's a bias already. The bias is that they only survey people living in HDB. Okay, that's one. Depending on the time of survey, if they survey only on weekdays, then you also miss out the working people. Okay, so some things are something to think of. So everything can be applied. Okay, so then one way is to compare the responder and non-responder. You can still get some, okay, this is a question they always ask. How do you get the non-responder to do a survey? Be funny, right? How? The answer is you can't, right? But you can estimate. You at least know they're male or female, right? You at least know who they're Chinese, Malay, or Indian, right? So you can estimate. Or some people are not happy to do the survey, but they don't mind telling you certain things. Yeah, for example. Okay, so you can note down maybe their age group, their gender, their race, things like that. Whatever they tell you. You may not want to do the survey, but at least you can note down in general who are the ones that is rejecting you. Is it younger cohort, the older cohort, the male, the female, and so on? Okay. So these are some ways to minimize selection bias. Okay, any questions? Okay, don't worry, later I have questions for you. So okay, we talk about case control studies. So case control studies are very biased. Why? Because the cases you know, but you control the controls. Who are your controls? So these are prone to selection bias. So the design and critique must be very important. Who do you choose the control from? Let's say you want to do a case control study of asthma patient. Okay, so who's the control?
The non-asthma. No, not no. I mean, as similar as the one.
Yeah, it should be as similar, right? So can they have respiratory disease? So are you going to look, are your controls going to be a general population? Or are you choosing those with respiratory disease other than asthma? Who are controls? Think about it. Okay, there's no answer. Okay, because both answers are wrong. If you choose a patient with respiratory disease but no asthma, the reason is wrong is because the selection, the criteria your results you find may not be related to asthma, but may related to the other respiratory disease like COPD. For example, if you do a control study to look at asthma versus COPD patient and found that asthma patient live longer, maybe it's not asthma patient live longer, it's COPD patient live shorter. Okay? But if you compare to the general population, also not correct because they are not really the same as asthma patient. So your control selection is very, very important. Therefore, if you choose different controls, you may have different results. Okay? So selection bias can affect the study validity. So it must be important to account for this in the study design and evaluation. So when we write papers, we talk about all these biases under limitation. How do you address the biases? Okay? Okay. Any questions? I hope you still remember what is case control study. If not, can you go and revise back. Okay.
Rare disease.
Huh?
Like what you
For
said.
usual rare diseases, because you don't want to follow up enough time. Okay, then we talk about information bias. Okay, this one I spoke to my friend who is doing a master in public health. She still don't understand this. Okay, so the way to do it is very simple. Just remember this thing called misclassification. So this is due to your misclassification of either the exposure or the disease status or both. So your estimate is biased. Okay, what does this mean? There are two types. One is called non-differential, one is called differential. Okay, non-differential means the error is both sides. Okay, so error is both sides. This is not a big problem because they'll usually cancel out each other. Differential bias is the one that affects one side more than the other side. Okay, what does this mean? Okay, I hope I have an example. I'll give you an example soon.
It's like those who smoke will fake smoking, but those who don't smoke will fake it.
Will not fake that they will smoke. Yeah,
Mm.
correct. Good point. So yeah, see, yeah, very smart. So for those who are smoker, they may say they are non-smoker. But for non-smoker, they will almost always never say they are smoker. So when there's a bias, this bias could be a non-differential bias. Sorry, differential bias. Okay. So example, when the error occur equally among the cases and the control, or those that are exposed and not exposed, the bias always towards the null. For example, trying to recall your exercise. Trying to recall exercise. Okay, it could be either non-differential misclassification, means that the recall is the same. Those who are fat, those who are not fat, their recall rate is the same. Then it's called a non-differential misclassification. But if the fatter people will tend to either exaggerate or under-exaggerate the exercise, then it becomes the other way around, which is the differential misclassification, which means that the error occur unequally. This is the worst because this one you can't tell. Because if you can't tell, it can either be towards the null and towards away. Okay, maybe I explain a bit more. What does bias towards the null mean? You know what is a null hypothesis? Okay, null hypothesis means there's no difference. So when you have this non-differential misclassification, because of this, it usually bias you towards the negative, means you cannot detect a difference. So this is very conservative. So when you have non-differential misclassification, the worst case scenario is you don't detect anything because it bias towards the null. On the other hand, this is the worst scary type of misclassification because it can bias towards or away from the null. So you may be able to pick up something that is not there. These are a false positive. So for example, in Ernest cases, you say that the smokers will always say that they are non-smoker. Well, some of them will say they are non-smoker, whereas the non-smoker will not say they are smoker. Because of this, if you do such a study, it may found that there's a effect when there's no effect. Okay? Any other example of differential misclassification?
Vaping.
Yeah, VP is another example. Could be a differential misclassification. People who vape will say they don't vape, but people who don't vape cannot say they vape. Okay, so these are some of the errors that may occur. So must be very careful. Yeah. Okay, this is very common. It's called individual bias. So, for example, in the interview, okay, so interviewer see there's a smoker, he may ask more questions. If the interviewer see there's non-smoker, he may ask minimal question because he already by knowledge that this one not going to have any issue, so you don't ask him question. But if you're a smoker, you ask you got any family history of lung cancer, got this, do you have all this COPD, all this? If a non-smoker, he say, you got any medical condition? Oh no, okay, no. Then the bias is there already. Because for the smoker, he asked a very detailed medical history because they ask whether you got lung problem, you got COPD, you got lung cancer, blah, 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 blah. Okay, that's why, what must we do? One way is to blind the interviewer. Just ask questions. Don't tell them these are the control cases. Another way is to standardize the data collection protocol. Just because you are the control doesn't mean you just ask a few cursory questions. The whole process must standardize. Otherwise, you introduce the bias. Okay, so make sure that that's why train interviewer must be trained in such a way that no matter whether the patient smoke or don't smoke, the number of questions asked should be the same. Everything should be the same, so they don't introduce bias. Anything to add, Sunshine? Or am I talking rubbish? Yeah, we do surveys, right? Yeah, please share the interactive session. Mm.
Nothing much, but based on what we have gone through until now,
Mm.
I think some some survey companies or some researchers they might try to minimize some of the biases, like for example, talk about trying to sample people to make sure that something the correct people.
Mm.
So protocols or like what you see here, protocols. For example, you give the example of the household survey, right?
Mm.
So the protocol could be minimum how many visits in the morning, afternoon, and night.
Yep.
For example, yeah.
Weekday and weekend. Yeah. Make sure not all weekdays.
So the protocol to get the data collection um, process is to adhere to.
Mm. They may also do stratified sampling. They sample different age group, different races to make sure there's enough to do this. So they make sure that the whole bias is not all Chinese, all Malay or Indians. You see. So there are some ways to make sure there's no bias in your sample solution data. Okay, very good point. Okay.
Yeah,
Yep.
question
Mm.
for the previous one.
Yep.
The differential, right?
Mm.
Like for the example of the smoker and the non-smoker.
Mm.
So let's say you got two groups. The smoker they're trying to test smoker versus non-smoker.
Mm.
So smoker will have some that say they are non-smoker.
Yes.
So in your non-smoker group, you'll have a combination of smoker and non-smoker. In the
Yes.
smoker group, you need a smoker.
Yes.
So this may make the effect that you want to find harder to, because it kind of dilutes the non-smoking population.
Correct. And also, none of the non-smoker will say they are smoker. Therefore, the error is on one side, cannot go to the other side. So your smoker will always be too low. If
Yeah.
it's equal, right? If the smoker can lie they are non-smoker, the non-smoker can lie that they are smoker, they may cancel out.
Yeah,
Mm.
but this kind of dilution makes the effect even harder to figure
Yeah.
out.
So you're biased towards the now, so you cannot detect a difference.
Mm.
Mm. So you may have to probe deeper. For the non-smoker, you have to ask, have you ever smoked before? Okay, or you ask again, are you sure you never smoked before? Then sometimes people will say, okay, actually I smoked last time when I was younger. I still a social smoker, but I generally don't smoke. You see, so this means by when you ask question, cannot ask a simple, are you a smoker, non-smoker? You have to go on further. Like, are you a non-smoker? Are you an ex-smoker? Are you still smoking? Or they say, oh, I smoke, but I don't inhale.
So when will it be biased away?
Okay, bias away is where this one I must find example. Okay. Offhand cannot give an example. So bias away is when the group that has so you can think of a situation where you're trying to see whether wow, this is a very good question. Let me think what's the example. Okay, so when there's so let's say there's A and B, right? So A will typically say that they have something right when they don't have something. Okay, for example, exercise. No, exercise is a bad example. What is a good example? Let me think. What's a good example? I can't think of any example now. But okay, so let's assume that what is the thing?
Does it happen if there's like another variable?
Okay, example. Okay, example is okay. So some people get good grades, right?
Mm.
Okay, so then they'll say that what is the result of you getting good grades? So you ask people, those who get good grades, what do you do? They say, I study very hard. Whether they study very hard or never very hard, they may just say they study very hard. Then you erroneously thought that studying very hard is a contributor to good grades, but it could be other things as well. Yeah, so this is what happened when you ask a thing and people expect to answer a certain way. So even if let's say the study rate is the same for both sides, male and female, but because one side think that results is result of studying rate, they may over tell people that they study very hard. Then you erroneously thought that studying hard, this factor is associated with good grades, but it doesn't happen. Okay, so this is an example. For better example, I'll give you more later, okay? That's a very good question, okay? But it's very confusing because it can be either way. That's why this question always come out. So when there's a differential misclassification, it can go to either side. So that's why you need to carefully define what error does it go to, and therefore you can answer this. Because this question always call on. This is very simple. This one non-differential always go to the now. Make it less harder to get the effect size. But this one can go either way. That's why my friend is confused by this question. Yeah, she always asks me. I always say, okay. This is the model answer, Yeah, what else can it be there? Okay, interviewer bias to cover this already. Or when interviewer bias, okay, for example, another thing is that the interviewer may keep asking questions. Let's say you know that you have lung cancer. Then after they say that you smoke, I never smoke. Are you sure? What about your wife? What about your husband? What about your friend? You got smoke or not? You sure or not? No smoke. Sure, no smoke. Neighbor? Neighbor smoke. My teacher smoke. See? Smoke. Your teacher smoke. That's why you exposure to secondary smoke. That's why you got lung cancer. You see? This is by interviewer bias because they have idea that is already related, so they'll try to pry all the different way. Then another guy is a non-smoker. Then even lung cancer, ask you do you smoke? Occasionally lah, no more smoking, right? Okay, no more smoking. See, no lung cancer. You see, that's how happened to all the interviewer bias. Okay, that's why I must choose interviewer less judgmental. Otherwise, you may end up with all these things because the way you ask question very different. Yeah. Okay. Okay, move on. Why you look very amused?
No, I think so probably if you're talking more about qualitative and
It's the same question.
things,
Yeah.
I guess the researchers have to ensure the interviewers adhere to certain
Yes,
protocols.
that's the important thing. Standardize the data collection.
Reduce the degree of freedom
Mm.
interviewer can have.
Don't have too many interviewers.
A
Huh?
robot.
Even that's one thing you want to do.
Up
Even
to-
interviewer, male and female very different. Yeah. If you get a young interviewer, people will not talk to the female. If you get an old man like me, no, talk to me. Then again, response rate very different. So all these things introduce bias. Yeah. Okay. Okay, recall bias. Again, people may recall past exposure differently. Like I always ask this question. Can you remember what you ate yesterday for breakfast? What did you eat for breakfast yesterday? Oh, can you still remember? What did you eat for breakfast yesterday?
I slept.
What did you eat for breakfast yesterday? Okay, you can remember one day, 2 weeks ago, what did you eat? How to remember, right? But some of these questions ask you, do you often eat red meat? Do you often eat white meat? Do you often smoke? Ask a lot of things in the past. So obviously there'll be some recall bias. Okay.
Recency bias.
Yeah, and also recency bias also. You read about lung cancer causing, say smoking causes lung cancer. Then you got lung cancer. They ask you to ask, yeah, I remember last time I got this guy, this idiot guy, always smoke in front of me. You see the recall bias. Okay, but whether it's true or not, I don't know lah. But he just blame it lah. People that do that. Okay, so how do you prevent it? Is to use objective measures such as medical records or biomarker. Asking is very unreliable. It's best to have some biomarkers. Okay. Okay, another thing is to also define your variable rigorously, very clearly what is the inclusion, what is the exclusion criteria. Your data collection protocol must be standardized, make sure you know what you're collecting. And then your measurement tools must be both objective, reliable. A lot of them needs to be tested, validated. Even how the question is being asked can affect the answers. So make sure every words are not ambiguous and you cannot misinterpret it. That's why you do a lot of validity testing. Okay. You ask Lisa about it, the face content, face value, content, validity, all these things. Yeah. Okay. Okay, confounding. Okay, so I think Ernest tried to explain what it is. It means there's a third variable or an extra variable, extraneous variable that can partially or wholly explain the observed association between the two variables, but it masks the true underlying association. Okay, confounding.
So
Okay.
it's not the offset, but it's part of the variable that has a linear.
Yeah, and it cannot be in a pathway. It cannot be in a pathway. So the example I always use is the lighter. Okay, lighter is not a confounder because people who smoke or use a lighter, right, is in a pathway. So it must be something else. Okay, any example I give? Let's see. Okay, so the exposure causes a mediator to cause the outcome. So this is in a pathway. For example, having a lighter causes you to smoke more. Okay, causes the lung cancer. So the lighter is not
Confounder.
yeah, it's not a confounder because it's in the same pathway. Only when it's not in the same pathway, then it's considered confounding. The example would be confounding by age is the most common example. So you have, let's say, exposure, let's say red meat. Okay. Okay, so typical example is okay. So the very common confounder is age and duration. So the example we did was diabetes. So which is causing you to die younger? Is it because when you have diabetes at a younger age, or you have longer duration of diabetes? Okay, so if we found that people with diabetes at a younger age, they die younger, or their worse outcome, is it because they got diabetes at a younger age, or is it because they have diabetes for longer duration? So what's the confounding? Okay. Do I got example or not? Let me see. Okay, got example. Okay, good. I just got example. Yeah, I forgot it. So I did this before Chinese New Year, so forgot everything already. Okay, anyway. So they found that higher birth order, okay, which means that if it's a second birth, third birth, fourth birth, it's associated with increased Down syndrome. Scary, right? the more children you have, higher risk of Down syndrome. Down syndrome is a retardation. Okay, not retardation. It's a it's an intellectual disability. Usually for genetics, usually they call a trisomy 18, trisomy 31, 23, 21, can't remember which one. So basically it's associated with this so they found the higher birth order. Is it true? Okay, why? Because the actual reason is because of the age, maternal age. Because the more birth you have, all else being equal, the person with the third birth order is likely to be older than the first person with the first birth. So maternal age is the actual confounder associated with both the birth order and the Down syndrome. And it's not in the direction, okay? Your maternal age has no relationship with your with the reason. The reason is because of maternal age. So once you adjust for maternal age, then the birth order has no effect. For the same maternal age, the birth order is different. So this is one way you can do for confounding. You stratify it. So let's say you think that age is a confounder. You take the same age stratified. That's why a lot of data, they always talk about age standardized, age stratified. Let's take age away. Okay. Another example is diabetes. Okay. So diabetes found that diabetes rate has gone up. Okay. But if you age standardize, the diabetes rate actually drop. It's just that our population is getting older. That's why there's higher rate of diabetes. Okay. So this is an example. Okay. Any questions? That's why after you stratify for age, there's no more effect. Okay. So 4 methods. Okay. One is to review literature. Okay. This is very simple. Don't reinvent the wheel. Go to literature and see what are the common confounders. Usually it's age, gender, all these are confounder lah. Okay. And there are 3 conditions. So a variable is a confounder if it's associated with the exposure. So in this case, age is associated with the exposure. The older you are, the more likely you have a higher birth order. The older you are, very likely you have Down syndrome. Okay, and it's not a causal path between the exposure and the outcome. Okay,
The third one, how do we know?
that's why I must go to literature and see. Okay, what's a causal pathway? It's not a birth order, it's actually the age. Yeah.
The third path may be unknown.
Yeah, if a causal path is unknown, then it could be a potential confounder. So what you do next is you can use stratified analysis. So what you do is you compare the pool estimate with the different strata of your suspected confounding. You think race is a confounder, you take the same race and then compare. So maybe in the Chinese, is the birth order affected? In the Malay, is it affected? Is the Indian is affected? Let's say in the Malay is affected, Chinese, Indian is not affected, and you found, okay, if the Chinese is affected, the Malay, Indian not affected. So the real reason why there's an effect is because of the Chinese, not because of it. But if it occurs in all 3, then race is not a confounder. And you can use a regression adjustment. So if the adjusted odds ratio differ by 15%, there could be some suggestion of confounding. But all these things are suggested. Okay. Okay, last part is about effect modification. Okay, this means that the effect size of the strength of the association between exposure and outcome depend on the third variable. And this is actually a natural phenomenon that should not be controlled but described. For example, for a certain condition, right? Let's say if you have diabetes, it will make the condition worse. So it's actually natural phenomenon. Do you have an example? Okay, so there's this randomized trial. You have a new antibiotics. Odds ratio for recovery is 1.5. Okay, so a new drug improves the recovery by 50%. If you do by gender, men is 1.1, women is 1.9. So sex modify the drug effectiveness. So this drug works better in women. Okay, so this is an effect modification. Okay, usually don't adjust for it. Okay. Because it's natural. Could be some reason why maybe female hormones or less testosterone, all these things that cause the drug to be better. Okay, so effect modification is not a bias or flaw in the study. It highlights real differences between groups. So for example, there are certain drugs that works better in Chinese compared to Malay Indian. And this can be because the Chinese are more compliant to medication. So this is a real thing. The reason why you're having this effect is due to the compliance issue. Actually, compliance could be a confounder. Okay, that's a bad example. Because compliance will be a confounding effect. Okay. So anyway, Yeah, so there's certain situation where effect multiplication is a natural consequence rather than bias or flaw. So to do this, you need to report it separately to show the real effect. That's what they did just now. Okay. Okay, key takeaway. Oh, finishing already. Okay, so systematic error, there's skew data analysis and interpretation. That is bias. Okay, this is remember. So there are two types of bias, selection and information bias. So selection bias is think of it as a person's bias, healthy worker effect. Healthier workers are healthier. Person bias is where your population where your control comes from. Information bias can be non-differential or differential. How do you mitigate through the clear criteria, make sure that the data collection is standardized, protocol is standardized. Confounding is when a variable distorts the exposure outcome relationship. For example, smoking generally can confound many of the alcohol lung cancer studies. You can do things like randomization, matching, stratification, multivariate regression. I think a couple of these. I'm missing. Funny. Okay, never mind. Examples of effect modification. The age, for example, gender can actually affect the age usefulness. And can do subgroup analysis and direction terms in model. I miss out the confounding one.
Hmm.
Missing. So sad.
Miss what?
Yeah, I missed the randomization.
Oh,
Okay, so these are some things you can do. You can randomize. Okay. Match, stratify, multivariate regression. Okay lah.
actually randomize, right?
How does it? Maybe it's not, you know.
Randomize it also kind of like is skewed by the population, like what's it called? The mixed.
Okay, I think something
it?
is wrong. Yeah, I don't think that's correct. Okay, never mind. I will. Something can be hidden slide, and the takeaway are affected by hidden slide. Okay. Okay, I have to go soon, so let's play the game quickly, and then we can call it a day. Okay, where's the game? Okay, let's start. All ready? Let's start.
Wait,
3 participants, right? All ready?
sure.
Let's go.
Reconnect.
Oh, okay, no worry. Wait, all ready? Let's start. Okay, hope this is useful. All ready? You know, 6068510. Okay? Very fast one, Ready? Huh? You can scan also. Go to joinmyquiz.com.
We're just waiting.
068510. So I can start. Go. I should join also.
Oh,
The secret is all different, so cannot copy each other. Okay, the leadership board is there. Samuel is leading. Ernest is leading now. Actually, don't need to record this. Closer recording.